Okay, continuing with section 2.2, we're on problem number 3. I kind of got cut off right in the middle of part A. So I was highlighting for you the areas that are increasing. They're in blue. So you're increasing or going up on the graph all the way from the x values that are called negative infinity, because this leftmost leg flares out continually to the left. So those x values would be called negative infinity. And then that increasing portion continues all the way until the value 2. So one of the increasing portions, negative infinity to 2. And then also there's another increasing portion where the graph is going up, and that happens between positive 3 and positive 4. Okay, next question, part B, asks where are the open intervals where it is decreasing? I highlighted those for you in pink. The graph is falling with respect to the y values in between 2 and 3. And then again on the rightmost side, again in pink, it also begins decreasing at the number 4 and all the way out into the positive infinity x values. So from 4 to positive infinity is also considered a decreasing portion. Remember, when you're giving interval notation, I'll keep repeating this just because there were some people on the test that are still not doing this. When you're naming an interval, name the smaller numerical quote number first, and then the bigger one at the end. Like when you're naming these two things, the further you go into negative infinity, the smaller it is. So that's considered the smaller numerical notion here, and that's considered bigger. So that's one of the rules of interval notation. Open intervals on which the function is constant, there aren't any because there's no flat areas on this graph. So there's none of those. Okay, moving on to number 4. Number 4, I'm going to try and start, getting you to a point where you can answer the question by hand, by calculator, and you are definitely, when you're doing it by hand, able to show your work. So there are a couple of different questions. I want to help you be able to read the question and understand what they're asking. So in this question, I'm going to label some things for you so that when you see this kind of wording in MyLab Math, you're going to understand what it is that they're asking you for. It's a matter of you getting used to the kind of terminology that is used with respect to specific types of questions. So you guys are, beginning to study graph theory, and some of the things that we like to talk about when we are examining a graph is where is it increasing and decreasing? What are the high points and the low points, also known as relative maxes and relative mins? And there's specific wording that they use when they are trying to get you to examine the maxes and the mins on a graph. Like for instance, you're going to notice in number 4, part A, that it says use the graph to find any values at which the function, this is a picture of the entire function, name any values at which the function has a relative max. When they say find the values at which there is a max, they're talking about the x values. So let's put that down here so we're clear, because there's certain things they'll say when they want you to come up with the x value at which the max occurs, and certain ways that they will word the question, certain wording that they will use when they want you to talk about the y value. So the value at which the function f, that's just the name of the function. Functions could be called h of x, g of x, s of x. They can have any kind of name. This happens to be called f of x. So value at which the function has a relative max. A max, if you want to put it in layman's terms, is the high point on the graph. This word relative, you're going to see that it is spoken about differently in books, but relative is a very common way to refer to it. It just means that in a specific locality, what is the high point? Like, for instance, in this specific region right here, in this local area right here, the high point is right there. It occurs at an X value of 1, and the value associated with the Y value associated with it is 2. So this value that they're talking about at which the relative max occurs, yes, that is the high point here, but it's not really the highest point on the graph. The highest point is shown right here on the rightmost leg. See how this leg, well, the window has cut it off, but in all actuality, if you were to expand this window, this leg would go up, 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 all the way to positive infinity with respect to its Y values I'm talking about. So that's where it maxes out. But you can't talk about a specific value if you're going to talk about the portion of the graph that goes off into infinity with respect to the Y values. So we talk about what's called relative max and relative min, where we could actually put a finger on the Y and the X value at that specific region. So we use the word relative when we're talking about a max or a min in a specific locality of the graph. Okay, this is what we would call a max, a high point. This is what we would call a min. So, if you want to put those layman descriptions of this, you could call a max a high point. You can call a min a low point. You want to label that into your notes. You should be taking notes with the outline. I can't imagine someone being able to take the notes and drawing and writing all of this stuff out. So please print it when you're going to look at the videos and take the notes. You'll find yourself scoring a lot higher because not only will you be getting used to the terminology, you'll be getting used to looking at the graphs as we discuss certain topics. And really, that's the only way to get a good grasp of what's going on in the class, when you can look at something visually and discuss certain portions of the graph and handle the answers either by hand or by calculator. So very important that you print these out. So again, you might want to label that high point and relative min low point. So again, this wording that they're using. Find any values at which there's a relative max. When they say find the values at which there's a relative max, those values that they're talking about, and there might only be one value, they're talking about the x's. Whereas in the latter part of this same sentence, look at the wording that they have now. To calculate, find the values at which the relative max occurs. That's the x value. In order to calculate the actual relative max. So when they talk about the actual relative max, then they're talking about the Y value. And I guess I could just put that right here. So you are to read the question, the front portion of the question and the back portion of the question, and notice that the wording is different up towards the front of part A as well as part B. It'll say, find the values at which the relative max occurs. They're talking about the X. Then when they say actually calculate the actual relative max, that's when they're talking about the Y partner that goes with this X partner. Okay, so how can we handle the kind of questions that they're asking? Notice that it says use the graph first of all. So we're going to do it that way. I'm going to teach you several ways to tackle this problem because you're supposed to be, in this class, you're supposed to be becoming savvy in using the calculator, but mainly doing it by hand. The calculator is only to be used to back you up and to back up the work that you're doing on your paper. So be careful that that is the main way that you know how to do a problem, because a calculator answer, if that's all you can do, that will not be accepted. In fact, it's going to be mandatory that you know how to calculate by hand. This problem makes you do all of that. I'm just going to give you some extra little toys for your pocket that you can, as you do your answer by hand, you'll have a way to see whether that answer is right or wrong by using your calculator as an answer key. Okay, so like for instance, let's go after part A, where it talks about the relative max. So if you're doing it by looking at the graph, you can see that this is a max. Where does it happen? At -1. So at x equal to -1, the function f has a relative max. So you're answering the front part of that question, and then use the equation to calculate the relative max for that value. So at the x value called -1, the function does have a relative max. So if you want to use the function to get the y partner, you go like this. You take the function, you plug in the x value. See how your function says f and there's a place for x? That place is to state to the reader of your work, which is me, what you're about to plug in. And if you're stating that you're going to plug in a -1 right here, that means you're plugging a -1 in everywhere. Everywhere that there's an x. And then you're going to show that you can do these calculations. And you can put this part in your calculator if you want to, but that's a mess to plug into your calculator. I mean, I would know how to do part of this at least by hand. Like in general, you should understand that when you're raising a negative to an odd power, it ends up being negative. When you raise a negative number to an even partner, every negative cancels out the negative next to it. So this comes out positive. This comes out negative. Now, all you're doing is raising the number 1. And when you're multiplying a whole string of ones, it has to come out 1. So that's the numeric portion of it. I'm just trying to get you to understand that when you raise a negative to an odd power, there will be a stray negative, which will make this exponential expression. It'll make it come out negative. Don't forget to drop the 2 in front of it. Then right here, this would be +1, but then you're multiplying by -6. Here, I forgot to put the -1 in there. Let me fix that. This is negative times negative. -18 times -1, that's +18 and +9. Okay, then you might want to put it in your calculator. And again, I can even write more. This is -2. This is -6. This is -18. And then that last number is +9. You might want to do some of it on paper instead of putting that whole thing in your calculator, but go for it if you want to. If you want to use it to do the powers and the multiplying and the whole 9 yards, you can do that. When you add these two things up, let's see what we get. And this is +18. I said it and then I did something else. This is supposed to be -18 times -1. Please write +18 there and also carry it down right there. Now put everything in your calculator. And when you put all these things in your calculator, you're going to get, let's see, -8 plus 18, that's 10. 10 plus 9, you're going to get 19. Okay, so I can write here that the function evaluated at -1 is equal to 19. That can also be written as a point. So in answer to this first part of the question, what is the value at which the maximum occurs? -1. What is the actual relative max? 19. Okay, so this is the value x at which it occurs. This is actually the relative max. I'll continue in the next